In this short video, I try and explain the event study with an example. Task number 1. What is the logic behind event study? Task number 2. What is the impact when the stock with the ticker symbol of HSIC, Henry Schein, was added to the SP500 index on March 18, 2015? For the event study, actually we have two periods. One is called the event window, another called the evaluation period. Look at this timeline. At time 0, so this 0 is called the event day. If the company make announcement they are going to issue new equity on specific date, so that is called the event date. However, sometimes even event day we cannot decide. If a company make an announcement at 10 a.m., then we can call it event day because the market will react immediately. If a company make an announcement after 5 p.m. when the market is closed, then correct event day may be n+1. Okay, so usually to avoid this dilemma, researchers use n days before, m days after. So this is called event window. So we look at this event window, then we look at the expected value, we look at abnormal return. Okay. Then we have so-called evaluation period or estimation period. And we assume this is normal period. This is normal period. We apply the capital asset price model. We estimate the model for the stock to follow. Usually we have several days gap between event window and estimation period or evaluation period, because we really don't want our event has any impact to influence our estimation. This is our procedure. Our hypothesis is there's no event on March 18, 2015. Step 1. Sort price from oldest to the latest. If you input data in the correct order, it is fine. Step 2. Estimate daily return for both stocks and for the index. Step 3. Define our event day and event window. We know event day is March 18, 2015. For event window, we can suppose it's 3 days before and 3 days after. So 3 plus 1 plus 3 equals 7. Step 4. Define our estimation period. Usually, we use 252 trading days. Step 5. Estimate alpha, intercept, beta, slope, and standard error. So for the standard error, Excel function is STEYX. Step 6. Estimate expect return. Expect return is intercept, estimate from step 5, plus slope times market return. Estimates expect return, abnormal return, average abnormal return, and the cumulative abnormal return. In addition, we also estimate their corresponding t-value. T-value for individual abnormal return, t-value for average abnormal return, and t-value for the cumulative abnormal return. Step 7 is our last step. Make our decision. Accept or reject null hypothesis. Here I show the formulas we are going to use and the hypothesis we are going to test. For the evaluation period, we applied capital asset price model to estimate alpha and beta. Again, alpha is intercept, beta is a slope. This is equation number 1. We use individual stocks return against market index return, we estimate alpha and beta. For the event window period, we estimate expected return, abnormal return, average abnormal return, and the cumulative abnormal return. Expected return is defined as alpha plus beta times market return. Alpha and beta estimate from first period from equation number 1. Abnormal return is defined as realized minus expected. Actually, we can treat as surprise. Average abnormal return is simply the average of abnormal return. Cumulative abnormal return is simply the summation of abnormal return. Corresponding to abnormal return, average abnormal return, and cumulative abnormal return. In order to calculate their t-statistics, we need standard error. For individual abnormal return, from running regression, we have standard error STDERR. It's from STDYX function. For the average abnormal return, is simply this value divided by square root of n. For cumulative abnormal return, this value times square root of n, where n is defined as the length of our event window. In total, we are going to test 3 hypotheses. Number 1, abnormal return of individual data is 0. Number 2, average of abnormal return is 0. Number 3, cumulative abnormal return is 0. This is a simple event study using Excel. We know that market index called S&P500 has 500 stocks. Over the time, some stocks for various reasons were removed from the index, while others were added. There's no doubt when this happens, it should have a big impact on the stock price of the company, whether its stock was added or removed from the index. On March 18, 2015, Harry Sheen stock with the ticker symbol of HSIC was added to the S&P 500 index. We expect this event will have a positive impact on the price of this stock. If you know the methodology of event study quite well, you are encouraged to download the dataset and do it yourself. Then compare your result with the result shown in this video. The event day is March 18, 2015. In the next slide, I will show a few ways to get the data. Please pause this video to get the data. If you are taking my course right now, you can use the first method. Otherwise, you can use method 2, method 3, and method 4. In this video, I'm going to use method 2 to get the data. To download the data, if we use the second method, we go to Yahoo Finance. So this is finance.yahoo.com. We enter ticker symbol HSIC. From middle, there's historical data. I'll click here. We have time period and show historical price. We have frequency. The frequency is correct. For the time period, we choose 02/03/2014. For the ending day, we choose 04/21/2015. then we click down. Then we click apply and click download. Okay, so this is our first dataset. Okay. To get the second one, then it's a market index SP500 caret GSPC. Okay, so this is SP500. This part is for historical data. And again, we choose the same time period. Starting day is 02/03/2014. Ending period is 04/21/2015. 02/03/2014, 04/21/2015. Click down. Then we click apply and click download. Then we have our second dataset. To make our spreadsheet look nicer, I'm going to hide some columns. Since we are only use adjust closing, so I highlight B, C, D, F, click hide. If you look at the date, so date will be the same. So we don't need these two columns. And again, adjust volume, date, open, high. So let's hide them. And also we don't need this one, so hide them. So this is return for stock. And so this is return for SP500. Then we calculate return. Okay, return equals today divided by yesterday minus 1. So this is our first return. Just click copy and paste. Similarly, we use return today's market index divided by yesterday market index minus 1. Then copy and paste. Okay, so this is alpha. So this is beta. So this is standard error or evaluation period. So let's choose 1, 2, 3, 4. 40 as our gap, length of gap. So this is our ending day of the evaluation period. So look at the row number is 276 minus 252. Why minus 252? Because this is the length. This is the length of our trading day. So it's 24. Okay. So let's hide some rows to make our spreadsheet more readable. So highlight one row, Control Shift Home. Okay, so keep Shift key down. So let's move up to, so it's 25. Okay, right click, click hide. Let's move our cursor up. So this is our, so let's hide a few more. So this is hide. Now our spreadsheet looks much nicer than before. Next, let's calculate alpha, beta, and standard error. So this is alpha, beta, and standard error. We know for the evaluation period, the starting row is 24, is here, and ending row is 276. So let's color them red. So this is our Y column. So this is our X column. For the alpha, we use Excel intercept function. Okay. For the Y column is stock return. Start from row 24, ending row 276, comma, this is X column. We close, enter. So this is our alpha. We can do exact same things using Excel bit, slope function, and steYX function. However, it's a better strategy is we log this Y column and X column. We hit F4 once, twice, third time, and fourth time. Then we copy this twice. Then we replace intercept with slope. So the beta for this stock is 0.83. Then we replace intercept with steYX. So this is alpha, this is the beta, this is standard error. To make our next operation a little bit easier, we can define 3 names or 3 cells, alpha, beta, and standard error. So we click value of alpha, we click formulas, then here we define the name. We click define the name. So this is alpha name exactly as this one. Or we can change it to any name you want. Okay, so let's alpha. So this is S3. We simply click OK. Then we choose the beta value. So beta value, exact same procedure. Click define the name. Again, we can choose another name like beta 2, beta 3, something here, beta. And we just verify the cell is S4. So we click here, it's standard error. Next cell, define. So this is standard error. The cell, referred cell is S5. Okay. If we click name manager, then we can see exactly. So this is alpha, its value, and which cells. Then we can edit, we can delete, then we can add new ones. Okay. So let's verify it. Okay, so that's 1 plus alpha. Okay, we know alpha is 0.000256. So 1 plus, so this is S3. So 1 S3. So alternatively, we can also enter 1 plus alpha. Enter. So this is 1.00259. Now let's calculate expected return and abnormal return. Here I put the definition of expected return. Expected return equals intercept, actually is alpha here, plus slope times market. Remember, so this is market return. So, right, expect. So this is expected return. So expected return equal alpha plus beta times, again, so this is market, SP500 is market, so this is expected return. Expect return. Okay, let's copy and paste. So this is event window. Okay, So this is abnormal return. Abnormal return is defined here, realized minus expected. Abnormal return. The abnormal return is defined here. Abnormal return equals realized return minus expected. So this is realized stock return minus expected stock return. So this is abnormal return. Now we copy and paste. Because our hypothesis is whether it's 0 or not, okay, so corresponding t-value will be equals, so this is abnormal return minus target. Again, remember target is 0 divided by standard error. So this STDERR, standard error, actually is S5 here. Hit enter and paste. Okay, and in order to calculate T critical value, we have to know how many observations do we have, okay, and count. So this is for row 24 to 276. We have 253, roughly 252, 253. So this is T critical value. So T critical value is T. So let's assume alpha. Alpha is 5%. So this is significance level. So alpha is 5%. So T inverse 2 tail. So this is 5%. Degree of freedom is 253 minus 1. So it's 1.969, roughly 2. Okay, so this is our decision. Our decision rule is absolute value of T is higher than or equal to the critical value, we reject. Otherwise, we accept. Okay. Again, our null hypothesis abnormal return equals 0. For individual abnormal return equals 0. Okay. If absolute t-value is higher than or equal to this critical value, okay, we have to lock this one. We hit F4 key here. Then we reject. Otherwise, we accept. Okay. Obviously, 1.32 is less than 2. We reject. Then we copy and paste. Okay. So this is only abnormal return is statistically significant. And for the average abnormal return, so this is average abnormal return. Actually, it's mean. So it's average abnormal return. So this is average. Okay. To calculate its corresponding t-value, we have to calculate its corresponding standard error for the AAR. Okay. And the count N2. So this is N2. N2 is how many trading days within the window. So we know it's 3 before and 3 after. It should be 7. Okay, it's 7. Okay. So this is corresponding is STDERR divided by square root of N2. So this should be smaller. STDERR So this is 1. So this is corresponding t-value. Okay, t-value equals abnormal return divided by its corresponding standard deviation. So obviously this is very, very small, and the new critical value should be greater than, okay, so let's calculate again. Here is n minus 2. It should be very close to here. So our decision rule, no. Abnormal return is not statistically different from 0. Okay, so let's calculate cumulative abnormal return. So cumulative abnormal return is a summation of all abnormal return. Okay, all abnormal return. Okay, so its corresponding standard error CAR, cumulative abnormal return. So actually is STDERR times square root of n2. So this is n2. Okay. So what is t-value? So t-value is cumulative abnormal return. So equals cumulative abnormal return divided by corresponding standard error. The t-value is also very, very small. So our conclusion is cumulative abnormal return is not statistically different from 0.